This video accompanies learning IoT with Python and Raspberry Pi. In this lesson, you will learn how to use the network file system to share files between two Raspberry Pis. You will need two Raspberry Pis. Models 3 or 4 will work. One monitor, one keyboard, one mouse, and two power supplies. You will also need a sense hat. Both of these Raspberry Pis will be connected to the same wireless access point or Wi-Fi hotspot. The network file system is a native way for sharing files on a Linux system. An NFS server allows access by NFS clients to the directories on the local file system. When an NFS client writes to a file in a local directory that is mounted to an NFS share on a remote server, the files are stored on the remote server. The Raspberry Pi 4 with the Sense Hat attached will be the NFS client. The write humidity script will get the humidity from the Sense Hat and will write the humidity to the humidity1.txt file in the EnviroReadings directory. The EnviroReadings directory on the Raspberry Pi 4 will be mounted to the NFS share dir on the Raspberry Pi 3. The Raspberry Pi 3 will be the NFS server. The read humidity script will be run on the Raspberry Pi 3 to read the humidity1.txt file and print out the humidity. Boot up the Raspberry Pi 3. Go to the terminal and type in ifconfig. This will show you the IP address of the Raspberry Pi 3. The IP address of my Raspberry Pi 3 is 192.168.0.132. Your IP address will likely be different. Enable SSH. If you're not sure about how to enable SSH, please see the SSH lesson video for details on how to enable SSH. Disconnect the HDMI connector, keyboard, and mouse from the Raspberry Pi 3. Leave the power connected, since you will be establishing a remote connection from the Raspberry Pi 4. Attach the Sense Hat to the Raspberry Pi 4. Next, connect the USB keyboard and mouse. Connect the micro HDMI connector to the Raspberry Pi 4, and then connect the power. Go to the terminal and enter ifconfig in order to find the IP address of the Raspberry Pi 4. The IP address of my Raspberry Pi 4 is 192.168.0.126. You'll need to make a note of the IP address of the Raspberry Pi 4, since this will be the NFS client, and you'll need this information when you're configuring the etc/host.allow file on the NFS server, which you'll be configuring later on in this video. Let's SSH into the Raspberry Pi 3 from the Raspberry Pi 4. Go to the terminal, enter SSH pi at 192.168.0.132. Pi is the name of the user account which we're logging on with, and the 192.168.0.132 is the IP address which we found for the Raspberry Pi 3 when we entered ifconfig. You'll need to enter the password for the Raspberry Pi 3. Because NFS is not automatically installed on the Raspberry Pi, you will need to download and install NFS on the Raspberry Pi 3, since that will be the NFS server. Enter sudo space apt-get space install space nfs-kernel-server. In order to configure a static IP address, we'll need to edit the DHCP cd.conf file. But before doing that, we'll need to get some information about the IP address which was assigned to us by our Wi-Fi hotspot or wireless access point and the default gateway. You will need to type in IP space route to see what IP address was assigned dynamically by your Wi-Fi hotspot or wireless access point. Note the IP address of my Raspberry Pi 3 is 192.168.0.132. The network address is 192.168.0.0/24, and the default gateway is specified in default via as 192.168.0.1. We'll edit the DHCP cd.conf file to set a static IP address for the Raspberry Pi 3. Enter sudo nano /etc/dhcpd.conf. I will set the static IP address for WLAN 0 to be 192.168.0.130/24 so that the address will be on the 192.168.0.0 network. If you want the Raspberry Pi 3 to access the internet, remove the hash mark from static routers and set the IP address to the IP address which follows the default via as displayed when you ran IP route, and remove the hash mark from the static domain name servers and enter 8.8.8.8. You will need to add a DHCP exception in your wireless access point or Wi-Fi hotspots configuration so that the IP address of 192.168.0.130 is not assigned to another computer. Plus Ctrl O to write out, hit the Enter key, and press Ctrl X to exit. Next, you'll need to enter sudo reboot to reboot the system so that you'll have the updated IP address of 192.168.0.130. Next, SSH back into the Raspberry Pi 3 with the updated IP address. Next, you will need to create a directory where the files to be shared will be saved. Create a directory named shared dir in the home directory on the Raspberry Pi 3. You may name this directory any name that is allowed by the operating system. However, you should choose a meaningful name. Enter mkdir shared dir. Next, we need to specify what clients may access the shared dir directory. The /etc/exports file on the Raspberry Pi 3 contains a list of the directories that may be accessed, followed by the IP addresses of the clients that may access them. In addition, the IP address may be followed by a parentheses enclosed, comma-separated list of options. There may not be any white space between the IP address and its list of options. Let's edit the etc exports file by entering sudo nano /etc/exports. The /home/pi/shared dir is located on the NFS server. The clients that can access the share are on the 192.168.0.0/24 network. Enter an open parenthesis, RW, comma, root_squash, comma, sync, comma, no_subtree_check, close parenthesis. Press Ctrl O to save and press Ctrl X to exit. RW says that the NFS clients may read and write to the shared dir. Root squash says do not allow root access to the shared dir. Sync ensure changes have been committed to the shared dir. And no subtree check says do not enumerate all the subdirectories of the shared directory. Let's restart the NFS kernel server service by entering sudo service nfs-kernel-server space restart. This is to ensure that we didn't make any syntax errors in the /etc/exports file. Next, we'll edit the /etc/host.allow file on the system that's doing the sharing. We'll specify the IP address of the remote client or clients that will be accessing the share. The network daemon process and the client are listed. Notice in this case, the IP address of the remote NFS client is 192.168.0.126, and this is the IP address of the Raspberry Pi 4. Enter sudo nano /etc/host.allow in order to edit the host.allow file. The port map daemon converts RPC program numbers into DARPA protocol port numbers. The lockd daemon starts the NFS log manager. The mountd daemon implements the NFS mount protocol, which creates a table of the local file system directories, which are accessible to NFS clients. The rquoted daemon provides quote information on the mounted NFS share, and the statd daemon allows the NFS client to notify the NFS server of any locks which are held on NFS shares. If a match is found to any of these network daemon processes, access is allowed. Press Ctrl-O to write out the changes, hit the Enter key, and press Ctrl-X to exit. Enter sudo space service space nfs-kernel-server restart to restart the NFS kernel server service. Let's write a Python program on the Raspberry Pi 4 to read in the humidity from the sense hat and write the humidity and the day and time to a file. Go to Programming and Thani. We'll import from the time module sleep and seat time, and from the sense_hat package, we'll import the sense hat class. Within a try block, we'll create a new sense hat object by doing sense is equal to sense hat. We'll prompt the user to input the name of the file, we'll use a with statement to open the file in append mode as a sensor file, and we'll write out to our sensor file the humidity, which we access by calling the getHumidity method on the sense_hat object sense. We'll format this with 3 decimal places of precision. We'll write out the C time, which has the date and time. Recall that when a file is opened with a with statement, the file will be closed automatically, even if an exception is raised. Therefore, in the except clause, we'll simply print out information about the exception. We'll save this code as write_humidity. Let's run this code and enter the name of the file as humidity1.txt. Let's write the code to read the humidity file. We'll enter a try clause and prompt the user to input the file name. We'll use a with statement to open the file in read-only mode as the sensor file, and we'll read each line from the sensor file using a for loop for data and sensor underscore file. Again, if an exception is raised, the file will automatically be closed. Therefore, we'll only print out information about the exception in the except clause. Let's save this file as read underscore humidity. Let's run the read humidity script and enter the name of the file, humidity1.txt. And you'll see the humidity and the time and date are printed out. Go to the terminal on the Raspberry Pi 4 and let's do a secure copy of read humidity to the Raspberry Pi 3. Enter scp read underscore humidity.py space 192.168.0.30:/home/pi/read humidity.py. You're logging on with the user account PI, and the IP address of the Raspberry Pi 3 is 192.168.0.130, and the destination directory is /home/pi, and the destination file name is read underscore humidity.py. You'll be prompted for the password, so therefore enter the password for the Raspberry Pi 3. We'll create a directory called Enviro Readings, which will be mounted to the NFS share. Mount the Enviro Readings directory to the remote NFS share using sudo mount space 192.168.0.130:/home/pi/share space Enviro Readings. Go to the terminal on the Raspberry Pi 4 and enter mkdir Enviro Readings. The sudo mount command is going to mount the remote NFS share dir to the local directory Enviro Readings. If you go to the desktop on the Raspberry Pi, you'll see a folder that's named Enviro Readings that has a cloud in it. Let's run the write humidity script again, and this time we'll put the name of the file as the directory Enviro Readings and then humidity1.txt. If you double-click on the Enviro Readings directory, you'll see the humidity1.txt file. Let's SSH into the Raspberry Pi 3 from the Raspberry Pi 4. Go to the terminal and enter SSH pi at 192.168.0.130. Let's run the read humidity script by entering Python 3 read underscore humidity.py. We'll enter the name of the file as sharedir/humidity1. Recall that the sharedir directory was our NFS share. The read humidity script prints out the humidity as stored in a humidity1.txt file. In summary, you set a static IP address for the NFS server by entering sudo nano space /etc/dhcp cd.conf. You install the NFS service by using sudo apt-get install nfs-kernel-server. You created a directory sharedir that will ultimately be an NFS share on the NFS server. You edited the etc/export file to create a list of shares on the NFS server. You edited the etc/host.allow file with the access control list with the IP address of the remote NFS client. You created the EnviroReadings directory on the NFS client, and then you mounted it to the remote NFS share. You created and ran the write humidity script on the NFS client and wrote the humidity to the humidity1.txt file. You created and ran the read humidity script on the NFS client to read the humidity1.txt file. You next use SCP, the secure copy, to copy the read humidity file from the NFS client to the NFS server. You ran the write humidity script on the NFS client and wrote the humidity1.txt file to the EnviroReadings directory, which was mounted to the share dir on the NFS server. Then you ran the read humidity script on the NFS server to read the humidity1.txt file, which was stored in the NFS share dir.
Go to www.learningiot.net for links to where you can buy Learning IoT with Python and Raspberry Pi.